Hey, how's it going? This is Yu speaking to you. Today, I want to share an extremely powerful mathematical tool that is often used in competition mathematics called independent variables. Now, some of you might be familiar with the term independent variables since it appears in multiple areas including science. And yes, that is the independent variable that we are speaking about. But how do we apply the concept in competition mathematics? First and foremost, dependent variables are variables that depend on each other. For instance, for x plus y equals 10, x changes if y changes its value. However, unlike dependent variables, independent variables do not depend on each other. For example, for inequalities x is in between 1 and 7 and y is in between 2 and 5, the change in a variable does not affect the other. When solving problems, dependent variables often form functions such as a linear function. However, independent variables form x and y axes. And here I brought an example. The example is from 1998 AIME problem number 9 with different wordings. Ma and Phi take morning coffees in a cafeteria every day. They both arrive independently at the cafeteria between 8 a.m. to 9 a.m. and chew for m minutes, where m is less than 60. Find the value of m if the probability that either one arrives at the cafeteria while the other is in the cafeteria is 40%. Now, please feel free to pause the video and try it on your own if you find it intriguing. If you're ready, let's dive into the problem. Because both Ma and Phi arrive at the cafeteria independently, independent variables could be assigned for both. The segment of y equals x shows the instance where both Ma and Phi arrive at the same time. Now, the passage of time could be shown with a square because time flows equally for Ma and Phi if we ignore theory of relativity from Albert Einstein in context of the problem. Will log, or without loss of generality, if I draw a red line parallel to the y-axis from y equals x, the top end indicates the situation where Phi is entering while Ma is leaving the cafeteria. Points on the red segment are valid. However, any points located higher with the same x value are not valid. The same applies for all the other red segments. Now, using the reflective symmetry, a blue section could also be drawn. Only the colored section provides a case where the condition in the problem is satisfied. Therefore, the 40% could be written as the area of colored sections all over the possible cases, or the area of the square enclosed by the green segments. With further calculations, we found the value of m, which is 60 minus 12 square roots of 15. This problem has taught me to expand my thoughts on how to approach problems involving probability. If you enjoyed this problem and solution, please do not forget to hit the like button and subscribe for more videos like this. Thank you so much for watching till the end, then see you in the next video. Bye!